Numericals on combination of lenses. Question number one. Calculate the combined power and combined focal length if two convex lenses of focal length 20 centimeter and 25 centimeter are kept in contact. So formula for combined focal length is 1 upon f equal to 1 upon f1 plus 1 upon f2. So 1 upon f will be 1 upon 20 plus 1 upon 25. LCM is 100, 5 plus 4, that is 9 by 100. So F will be equal to 100 upon 9 centimeter, and power is equal to 100 upon F when F is in centimeter. So 100 upon 9. So this will be 9 diameter. Question 2. Calculate the combined focal length and power of combination of lenses if two convex lenses of focal length 20 centimeter and 25 centimeter are kept 10 centimeter apart. So formula when two lenses are kept d distance apart 1 upon f 1 upon f1 plus 1 upon f2 minus d upon f1 f2. So 1 upon f equals 1 upon 20 plus 1 upon 25 minus 10 upon 20 into 25. So if 1 0 will cancel out. And if we take LCM, 1 upon F, so it will be 100. So this is 5. This will become 4. This will become 2. So it will be 7 by 100. Now combined power P equal to 100 upon F in centimeter. So 100 upon 100, 7. So it will be 7 that. Now question number 3, an equiconvex lens with the radii of curvature of magnitude r each is put over a liquid layer poured on top of a plane mirror. A small needle with its tip on the principal axis of the lens is moved along the axis until its inverted real image coincides with the needle itself. The distance of the needle from the lens is measured to be a. On removing the liquid layer and repeating the experiment, the distance is found to be b. Given that the two values of distances measured represent the focal length values in the two cases, obtain a formula for refractive index of the liquid. So clearly, equivalent focal length of equiconvex lens and water lens is F equal to A. And focal length of equiconvex lens, suppose it is F1, so that is B, because it is given when liquid is there, in that case, distance is A, and when liquid is removed, then distance is B. So combined focal length will be A, and that of lens itself will be B. Now, applying formula, 1 upon F equal to 1 upon F1 plus 1 upon F2. So we have to find out F2. So 1 upon F2 equal to 1 upon F minus 1 upon F1. So 1 upon A minus 1 upon B. That is 1 upon F2 will be B minus A upon AB, which implies F2 equal to AB upon B minus A. Now we have got the focal length in two cases. Now Next case is consider the lens and mirror combination with the liquid. So here radius of curvature of first surface will be R1 and R1 will be minus R and R2 is plane mirror. So its radius of curvature R2 will be plus infinity. Now we can apply lens maker's formula. So that gives 1 upon F2 equal to mu minus 1 upon R1 minus 1 upon R2. So that will give 1 upon F2, which is equal to mu minus 1 and 1 upon R1, that is minus 1 upon R, because second term will become 0. So we have also got value of F2 as AB upon B minus A. So we can put this value here. When we put this value, so what do we get? 1 upon F2. F2 is AB upon B minus A. So we can write here AB and B minus A can be written in numerator equal to mu minus 1 times minus 1 upon R. So minus sign can be written here and then it will become A minus B. So A minus B divided by AB equal to mu minus 1 divided by R. So we can multiply by R side. So mu minus 1 equal to A minus B upon AB times R, which gives mu equal to 1 plus A minus B upon AB times R, which are final answer. Now, next question. Next question says an equiconvex lens with a radii of curvature of magnitude 20 centimeter each is put over a liquid layer poured on top of a plane mirror. A small needle with its tip on the principal axis of the lens is moved along the x-axis until its inverted real image coincides with the needle itself. The distance of the needle from the lens is measured to be 30 centimeter. On removing the liquid layer and repeating the experiment, the distance is found to be 20 centimeter. Given that the two values of distance measured represent the focal length values in the two cases, obtain a formula for refractiveness of the liquid. Here we have to find out the value of refractiveness because numerical values are given for other elements. So here the equivalent focal length of equiconvex lens and water lens. So combined focal length. F is given as 30 centimeter and focal length of equiconvex lens only, suppose it is F1, so it is 20 centimeter. Now, focal length of water lens is to be found. So it is F2. We apply the formula 1 upon F equal to 1 upon F1 plus 1 upon F2, which gives 1 upon F2 equal to 1 upon F minus 1 upon F1. That is 1 upon 30 minus 1 upon 20. So it will give 60 and 2 minus 3. It will be minus 1 upon 60, or f2 will be minus 60 centimeter. Now, next point is that the water lens formed between plane layer and the equiconvex lens is plano-convex lens. This lens formed is plano-convex lens. So here R1 will be equal to radius of curvature is given here 20 centimeters. So it will be minus 20 cm, and R2 will be infinity. So we can find 1 upon f2 equal to mu minus 1 times 1 upon r1 minus 1 upon r2. So we put the values. F2 we have got as minus 60, so minus 1 upon 60 equal to mu minus 1 times minus 1 upon 20, because 1 upon r2 will become 0. So minus sign can be removed and we can multiply this 20 here. So this will become 20 by 60 equal to mu minus 1, or 1 by 3 equal to mu minus 1, from where we get mu equal to 1 plus 1 by 3. So it will be equal to 4 by 3, which is 1.33. Now let's take one more question. Find the position of the image formed by the lens combination given below. Here three lenses are there. First one has focal length plus 10, second one has focal length minus 10, and third one has focal length 30 centimeter, and separation between first and second is 5 centimeter, and that between second and third is 10 centimeter. So let's see the image formation. For image formed by the first lens, so 1 upon V1 minus 1 upon U1 equal to 1 upon F1 for first lens. So this gives 1 upon V1 minus 1 upon for first lens. The object distance in the question, object is placed here, which is 30 cm apart. So U1 will be minus 30 equal to focal length of first lens is 10, 1 upon 10. So we simplify it. So 1 upon V1 equal to 1 upon 10 minus 1 upon 30. So LCM will be 30. 3 minus 1. So this will be 2 by 30. From where we get V1 equal to 15 centimeters. So the image formed by the first lens serves as the object for the second lens. Image is formed at this point, means this distance, which is 15 centimeter from first lens. And the second lens is placed at distance 5 centimeter from first lens. So we can say that distance of the image formed by first lens will be 10 centimeter away from second lens, and that will behave like object for second lens. So let's apply lens formula for second lens. So 1 upon V2 minus, this time object distance will be 10 centimeter. As I told you that image formed by this lens will be at 15 centimeter distance, and since these two are separated by 5 centimeter, then remaining distance will be 15 minus 5, that is 10 centimeter, and that distance would be object distance for this lens. So we write here 1 by 10, but this time it is towards right. So it will not be negative. So that is why here sign of u is kept positive. Formula is 1 upon v minus 1 upon u equal to 1 upon f. Focal length of second lens is minus 10. So here we will get 1 upon v2 equal to minus 1 upon 10 plus 1 upon 10, which will be 0. That will give v2 equal to infinity. It means image due to second lens will be formed at infinity. And now we consider third lens. So object will be assumed to be placed at infinity. So for third lens, it is clear that rays will be parallel and they all will get converged at its focus. So its image will be formed at its focus. That will be 30 centimeter. So we can say 1 upon V3 for third lens minus 1 upon U3 equal to 1 upon F3. V3, as we have seen here, this time position of the object will be at infinity. 1 upon V3 equal to minus 1 upon infinity and equal to 1 upon focal length 30. So this will give V3 equal to 30 centimeter. So final image is formed 30 centimeter right of the third lens. Thank you for watching.